So Mark, thanks, and thank you guys for showing up. I've never actually made it out to this. I just learned about it about 6 months ago when Paul came out, and it's really cool that this is a thing. And so I'm excited to talk to you guys about what we've been working on. And kind of this has been a lengthy journey for Devon in general, and for me it's felt like a much longer journey recently. So I kind of wanted to take you guys through what we've been doing, kind of where we started back when I probably started my career more or less at Devon, and our struggles with data and the platform that we've been building out here recently in order to address hopefully most of those problems. So my name is Billy Cummins. I supervise our data and analytics platform team at Devon. So our responsibility at Devon is to work with all of our different IT-focused, business-focused teams in building out the new and modern tool sets in data and analytics. So it's our job to identify what the right tools are for Devon, roll them out, prove that they work, make sure they integrate with all the other systems, as well as do some of the development on top of them to get those platforms going. So just at a high level, our overall challenge is historically we've done a lot of point-to-point integration, moving data around. It's really no different from anyone else. So when someone has a problem and they want to do something, they have to go identify the data. It's basically the big data challenge. So over the years that I've been at Devon, we have tried to address that in a variety of ways. The first one is a data warehouse, and I apologize that this visual is somewhat old, but I really didn't want to go update a really old visual. But in my time at Devon, there have been 3 data warehouses. I've helped build 3 of them, and there have actually been 4 total. So we love data warehouses, and we love to try to do them. And so really with a data warehouse, you know, we have our sources, SAP being primary. We have other data sources. We load it into a database to get all the raw data out and not impact the system. Then we process it on a nightly basis into pretty dimensions and facts. We process those into cubes, and then we build reports on it. And so in order to get anything done, you have to talk to someone in IT. They have to get it out of the system. They have to build a process to write it in the warehouse. They have to build another process to execute it in tabular. And then maybe you build your own report or dashboard, or they do it for you. And you have to go through a whole lot of jumps. So for us, the data warehouse pitfalls are a lot. So slow to change, like I said. If you want to modify, you're going to need a BA, a developer, a cube developer. You're going to have to go through change control. In the end, it's going to be about 6 months before you actually get what you asked for, and you'll forget that you asked for it. Our warehouse has always been very financially focused as well. So we've ignored Devon. We have a big accounting group, but we are not an accounting company. We're an oil and gas company. So we really lacked the right kind of focus on the right business critical functions. Our data warehouse is in HANA, and I don't want to spend too much time bashing HANA because it can do a lot of great things. But in general, for those of you that don't know, HANA is an SAP database. It's an in-memory database. So you can do modeling inside of it and present your data as a view, which is very powerful, except you're limited by the memory that you have on the box, and you're limited by the compute. And so Devon ran into a problem where we just couldn't pull any more data into it, and we couldn't do any more processing on top of it. Our warehouse at this point is basically full. Everything gets denied. In fact, I'm supposed to be in a meeting, or I was supposed to be in a meeting 30 minutes ago to basically hear that the warehouse team was telling them, no, you can't do that. Wait until everything's ready on this new platform. And then we limit access because it's going through the problems that it has today. We don't let everyone get access to the warehouse anymore. We actually restrict people's access to the raw data, and in some cases, we don't let them direct query in the database at all. They have to go through the serving layers that we've put on top of it in order to protect all of that. And ultimately, it's just expensive to build and maintain. There's a very large team that does all the changes and builds things in it. And then we have an even larger team that we call BIOM that does our operations work on it, both in the US and overseas. And it's just the nightly processing and everything that goes along with it is just a really big pain. Should I pause here for food? Or?
Yeah, we'll just do one row at a time.
Okay. So another solution we've come up with is data services. And data services are at a high level at Devon. It's what we refer to as our virtualized layer. It's really a misnomer because there's little to no virtualization in the process because ultimately you have to cache and store the data somewhere. But it's a little small for you guys, but I'll kind of take you through it. So the idea of data services is let's create enterprise objects on top of all of our data. So you get with a business user and you design, hey, this is what a well is. And it's very data warehouse in that regard, because it's a simple flattened out structure. And so that may pull from multiple databases, it may pull from the warehouse depending on what it's looking for. And it basically just caches a view of that data at whatever interval the business requires. And so it does a good job at overall exposing that data to people. And the biggest win is we actually kind of teamed business groups up with IT people in order to execute on what they needed. So it filled a gap that the warehouse previously was not filling. It can both cache the data and in some cases do pass through to databases if the database can handle ad hoc hits like that. And it could do fairly advanced transformations. At the end of the day, it's Informatica. So what I have here is kind of our different applications and our data warehouse, and we use Informatica Data Quality as our extract and transform engine as a part of this. And then we have a guy on our team named Nick Batley who built a custom OData layer on top of it. So we can present all of our data services through our API layer as OData and make that available to everyone in the enterprise and externally when we want to. And then ultimately we have it connecting to things like Excel, Power BI, and Spotfire, and an analytics tool we use called SAS. In some cases it connects great, in others it can be a little bit of a struggle. But ultimately we've had a lot of good success with this. Where we failed on this is that in general the data transformation and storage layer are not scalable. So we have an Informatica box and we went as big as we could, but ultimately we could only go so big. And then we have other pieces like the OData layer that sits on a JBoss server that we could only go so big with. And ultimately the way it's been architected and built, there's just a lot of points of failure. So Informatica could fail because too many people hit Informatica. Its strong suit is really not as a database. That's not what it was meant for. The underlying database for a pass-through could fail. The OData layer could fail. Our API layer is called HANA, and that could fail. And so users would just try and execute something against the OData layer and just nothing would happen. And so we would send a generic data services are down, and then someone would have to figure out, usually Nick would have to look at every single piece and find out where it was broken. In general, it still requires developers and change control, so we still can't just let people go free on it. It's still expensive to build and maintain. It's a different way of doing transformation. It's a different way of managing our data. So we have a separate operations group that just manages all of that, and we have developers and BAs and data modelers that help us build all that. And this is a weird problem, but we just have too many users. It was too successful. We hit a point earlier this year where we rolled out the last major implementation for some of our field work, and it just too many hits came in and everything started crashing all the time. And then the last way that we've tried to handle this is through basically a self-service database. And our self-service database is called EADM. I don't even know what EADM stands for. I assume the DM is data mart, but I just don't know. I was going to create a visual for this, but it would have been too frustrating. So I just in words said, it does this, it does this. So bear with me. Ultimately, this is actually built on our big data platform of the past, what we run, which is Cloudera on-prem. So data is loaded into Hadoop. We have a nightly process that gets lots of data from lots of systems and dumps it into Hadoop. Data is extracted from other sources because we didn't get everything they needed using a tool called Datamir, which is a data wrangling tool. Data is transformed using Datamir. So a user will just go out and do whatever they want and do a transformation. They will write it back to our Hadoop cluster, Cloudera, but that's only because that's what Datamir makes it do. They will then write another job that takes that data and pushes it out to this EADM SQL Server database. And then in some cases, that wasn't enough for them because Datamir couldn't do everything they needed to do, so they'll create views or store procedures in EADM in order to continue to massage the data. And then ultimately, and this was the terrifying thing, there are important decisions that are made using Power BI and Spotfire. So we have a bunch of people doing all sorts of things, and we just have no idea what they're doing. So ultimately, the pitfalls that we saw here was, again, we just don't know what's going on. They build whatever they want, which is great, but as downstream processes start to be built out, we don't know what jobs we should be watching on a nightly basis, if they're actually business critical. We actually started an effort to start retiring this, or we're in the middle of an effort, And they basically handed us a list of 1,200 jobs that they said, these are absolutely business critical. And then after back and forth, we got them down to 800. So we're in the process of trying to convert 800 into the platform that I'll show you guys here in a minute. So they obviously think highly of the work that these business users have done over the years. Again, limited support. All we can do is keep that database alive. We can keep Hadoop alive. We can keep Datamir alive, oftentimes by just bouncing it every once in a while. But we don't know what's critical. And I say the transformations are proprietary. That probably should have been in quotes, and that technically they're not. So Datamir creates MapReduce. At least the last time I Googled it, that's what it does. And that MapReduce, to me, is somewhat legacy, I'd say. It's not what we want to use. And machine-generated code is just ugly. So if we did try and take all the code out and try and convert it, we would just fail. So that kind of took us to our basic goal as we looked across the landscape and everything else we had going on. How can we do this better? So the basic premise of what we wanted to build was accessibility from all of Devon's tools. We want to make sure that whatever people are doing, whatever tool they're using, we're not going to be able to control necessarily, but we need it to work on our platform. We need it to scale to serve all of Devon's structured and unstructured data. Today we're going to focus on the structured side, but ultimately we need it to be able to scale to what users are doing. Handling all workloads, so whatever someone's doing, if it's a giant deep learning process or a simple Power BI dashboard that they're putting on top of the database, we need to make sure that it can handle it. Gives users access to both raw and curated data, get them out of the place where they have to go to individual systems when they want data, as well as give them convenient and consistent access to the data that we've actually curated and said this is enterprise grade. And then simplifies our overall stack. So how can we get better by also just making everything easier for us? So pretty straightforward goals overall. And with that, we created what we have called the Data Hub. The Data Hub, a hub is not really a hub and spoke is not really a new thing in the data world, but ultimately we wanted to have a centralized place where we can have bulk read, bulk write, and large processing against it. So there's kind of two sides to this. There's the transactional microservices side, and this is just on there to make it a pretty service or a pretty slide and make it look like we know what we're doing. This is a thing we're not even touching yet because step one is get better at all the other stuff. The other side is really the bulk read data services and the way that people need to interact with data so that we can connect our Power BI, our deeper analytics tools, and just our simple Excels and whatever else users are looking to do. So our basic vision around the Data Hub is making data more accessible, supporting new analytics capabilities, and ultimately just empowering people to create new data sets and gain insights from the data that we have. So we want to make it easier for people to locate data and access it seamlessly, transform, enrich, analyze, publish it, build algorithms and predictive models, be able to share all the insights that they get out of it, and then ultimately be able to quickly and seamlessly connect new data sources and systems to that. Our principles are fairly straightforward. We want to use, really I can probably summarize this with, we want to use managed services as much as possible. We want to get out of the game of managing anything we do. So Devon is an Azure customer, and our team was born in the cloud, I guess I'd say, in that we've only officially existed as a team for a couple of years now. And so everything we do, we got to ignore what we did before on-premise and build everything as managed service as possible. So if it says SaaS or PaaS, we're a lot more likely to consider it and we're a lot more interested in it. And ultimately, we just want to be able to quickly deliver tangible value to our end users. So that takes me to our Data Hub technology. So ultimately, the Data Hub has three main components. There's a whole lot of other things that happen under the hood, but I'm a supervisor, so I don't understand it. Ultimately, it's Snowflake, Databricks, and Attunity is what makes up our Data Hub. So Snowflake is a data warehousing technology. It is our structured data lake. Databricks is Spark Engine, the creators of Spark. So it's for our transformation, big compute, machine learning type activities. And then Attunity is a structured data replication tool. So that's how we get the data into the platform. So in general, there's a few other tools that you'll see on here that are kind of the edge cases when we need to. But we have our source systems, we have our data replication layer, which is primarily Attunity, pushing the data into our data lake or the data hub. And then data transformation primarily using Databricks. And so there's kind of an ongoing loop with people, with users on how they interact with that data using Databricks. So I'll drill into that a little bit more. So Snowflake is new to Azure, and so we were very excited when we learned that it was coming to Azure, because it was something we had watched for a while on AWS. And when I look at it as a big data approach to data warehousing. It basically takes all the troubles that we had with data warehousing previously and all the troubles that I've seen from the big data space and just simplifies a bunch of things. So it has massive data storage capabilities. In Azure under the hood, it is just Blob Storage. And then it separates compute and storage, much like the big data idea. So you store the data in Blob, you pay next to nothing to keep it there, and you only pay when you're actually doing things on top of it. And you can individually size the warehouses, and the warehouses auto scale. So let me kind of take you through that. These are all very small, and I apologize, but basically what these databases on top of this represent are the data warehouses in Snowflake. So for example, this one is our data replication or our Attunity warehouse. So we can have an individual warehouse that is an extra small, and like I said, it's t-shirt size, so I can go extra small to 4XL. And when it's running is when you pay for it, by the second. So for a data replication one, I don't need a lot of power, I just need it on all the time and data pumping into it. So we will process data through this very small instance of Snowflake. And that is constantly then feeding our underlying blob storage layer. At the same time, we can have our OData layer that we're replatforming from Informatica into this, and we can have a medium-sized instance. So as people run OData hits, they're hitting this warehouse instead. And same thing if someone's running a giant their machine learning process against a bunch of data or unstructured data or whatever it is, they can hit this instead and not impact anyone else. So it allows us to separate workloads and insulate people from themselves and each other. So if somebody screws up and does something dumb in OData, they're not going to impact anyone that was accessing a Power BI report. They can still refresh and they won't have any problems. While everyone benefits from the ongoing data replication that's coming in through this tiny instance. So this had a ton of benefits for us and is really what ultimately sold us on Snowflake, which was that ability to only pay for what we're using and right size for every situation that we have.
Can I ask a question?
Yes, please do.
So how do you curb costs? How do you keep someone from just going crazy?
Well, so you can dictate how big it's allowed to get. So, oh yeah, sorry. So the question was, how do we curb costs? How do we make sure people don't go crazy? So technically, someone on my team is capable of creating a 4XL. So far, no one's done it because it actually doubles in price every level you go up. So it scales. It goes big. It's big data. But we limit who can actually modify the size of the warehouse instances as we got the platform up and running. Actually, as we did our POC, we got in a little bit of trouble with Snowflake. They were very nice about it, but we went a little too big and we used up our free trial a little too fast and they let us keep going. But you can basically say you're allowed to be between an X and an XL, and if it needs to go to an XL, it will based on the amount of power. But the other unique thing is if your workloads scale, a traditional query and the things that process in Snowflake, generally if you go twice as big, so if you go from a large to an extra large, because you really do get twice as much compute, then your job should run in half the time. So even if you go really big, if it runs in half the time and you're only paying by the second, you still paid the exact same price you would have paid for a smaller instance. So it's incredibly flexible. And we did a lot of cost analysis of that versus some of the other data offerings in Azure that I won't throw under the table. But cost-wise, we actually, once we estimated what this would cost, we just upped it because it felt wrong before we signed the papers, because we were like, just in case, let's go a little bit bigger, because we just couldn't figure out a way that we were going to use that much. And so far, we've underused it, so it's been nice there. But you have to be careful in all of this, actually. So I'll go to the next one then. So Databricks. You can, yes. With Snowflake, there's a tiny bit of legal work, but yes, ultimately you can. Yeah, which is also what's so great about the cloud. So Databricks is the other thing. Databricks was the thing that we identified probably first. When we were looking at Azure in 2017 was basically just a year of failure for my team. We were just depressed every day because everything we would try just wouldn't work the way we thought it would work. And it was a lot of work to even get it going, and it was just incredibly complex. Like the things that guys on my team were doing was way beyond anything a typical person at Devon would be able to handle. So it was, an ongoing fear of, is this ever going to be a reality? So when Databricks became a thing, it was just a slam dunk from a Spark perspective. It is Spark ultimately, and it's a notebooking experience. So the front end to Databricks is just a notebook. You get to open it up and run small snippets of your code and see kind of as it evolves. It allows you to save your code in a shareable space, so you can give someone else access to your code. You can both be in there doing a notebook at the same time. We've had people co-develop things together, a data scientist and one of our developers, one working on the distributed compute and the other one working on his algorithm in order to run these. And then you can ultimately schedule the runs. So it's a safe space for people to do their work in. It also, and I have to emphasize, it is coding for all. There isn't a pretty front end, no matter how much we yell at Microsoft and Databricks to put this on top of it. You do have to ultimately do coding, but there's a lot of options. So you can do PySpark, Scala, Java, Python, R, or for many of our users, SQL. So we encourage people we're not going to tell you what you can or can't do in it. Do whatever you want. If we ultimately need to support it, then maybe we change the conversation a little bit. But if you learned R in college, have fun. Our team only really knows how to do Python, so that's the thing we're going to push, but you can do what you want. And it also natively reads and writes from Snowflake. Technically, their documentation said it did on day one. We tested it. It wasn't working. It was very slow. And in a day, they turned it around and said, try it again. And it just worked. So we look at it for us as much as possible as the front end of the data hub. When someone wants to query Snowflake, ideally, we don't want them to know Snowflake is there. Everyone knows the name Snowflake because everyone hates the name Snowflake, so everyone gravitates to it. But we want them just to think, I'm going to the data hub, I'm going to write a query, and we want them to use Databricks as much as possible so that whatever they write is stored and saved in the notebook. They can schedule runs when they're ready to do that if that's something they want to do. So that's kind of our goal for that. Yeah. So we have not yet to date. Sorry, I'll get better at that. The question was, do we tie users to specific Snowflake data warehouses, and what does that look like? It kind of depends. So for like Databricks can only access certain warehouses, and we control that. Same thing with Power BI. We have to connect something to the gateway and get that working. So we generally own some of that, and we get to decide what warehouses people can see. So some they can see and some they can't. But in some cases, I would say we're not quite as granular on some of our security that we'd like to be. So it's still a little more open than we probably want today. The last piece is Attunity, and I'm all about being as open as possible. So I will say, of all the pieces, Attunity is the only non-managed service, and it's also the thing that we are struggling with the most. So Attunity is structured data replication. It can sit on top of Oracle, SQL Server, and HANA. And ultimately, when changes happen, it catches it in the logs, and it pushes it over to Snowflake. So we're in the process still of kind of building this out and getting it stable. It is replicating lots of data right now, but there's a bunch of things that we've had to chase down and figure out what's not working or why latency is especially bad in certain databases, but not others. It does have some transformation abilities. It's somewhat limited, and you obviously need to be careful about how much you're going to transform on the fly. But if you want to add audit columns and things like that, you can. And it can write to Kafka. So when we looked at it, we said, well, that's great. It'll replicate to Snowflake. But with time, as we start to try and build out more microservices and more streaming integrations and things like that, we can start pushing things to Kafka, and then just that fits into our streaming pipeline with NiFi and other tools. So overall, it was the idea of it and what it can do for us is an absolute slam dunk. just getting it implemented and getting it going the way we want it to has been the biggest challenge.
So you mentioned getting data to Snowflake via Kafka.
Yes.
How does that work? Is there a data connector for Snowflake to Kafka?
There is not, no. So we had planned, we haven't bothered to do it yet, just because everybody at Devon thinks they want streaming until you have the conversation, and then they realize they don't want streaming yet. So our intention was likely just to use NiFi or something like that as a quick push to Snowflake. So, I'll step back. So this is kind of the Data Hub technologies and all the different things, but right now we're feeding data into Snowflake. So we're kind of cheating on some of these, where we say, well, let's go ahead and put the data services into Snowflake, and let's put part of the warehouse into Snowflake to make it available there. But ultimately, we need to actually start migrating everything into this space. So we have data services, we have a data warehouse. Why would we do data transformation in two different ways and just create more confusion? So our first pass at that is, I say it's in development, it is and it isn't, and then it's partially done. Basically what we call data services 2.0. So our data services layer is successful, and we've pushed that data into Snowflake, and we've rewritten our OData layer to sit on top of Snowflake, so that instead of people hitting Informatica, they'll hit Snowflake without knowing, which is the dream and the idea behind a data services layer. However, we're still dependent on processing in Informatica and a lot of ongoing operations work and things like that. So our data services 2.0 is natively built to sit on top of Snowflake and take advantage of all the scaling that it can do, as well as pass through a lot more information, give us a lot more auditing capabilities of what's going on, and do the dynamic scaling that it can do.
Is that still an in-house build?
It is still a completely custom thing. What we did get better at is this says Docker, we moved to Kubernetes. We actually moved our old infrastructure over too, because again, everything was breaking, so we just went to production 2 days ago with that. So our two versions of our OData layer now sit on top of Kubernetes and can scale and handle the workload that they get. And then ultimately the underlying data for that, it comes out of Snowflake. So for us, the next project, the thing that really starts migrating us into everything happening in this platform versus some of the disparate things we have going on, is moving those data transformations into Databricks. So taking the things that we have today that transform in Informatica and rewriting them in PySpark and SQL and Python. And then once we get done with that, taking everything we do in HANA today for our data warehouse and rewriting it in this, creating one place where everybody does all of their data transformation work and all of that. So kind of what this does ultimately, and what we've been trying to aim towards, is getting everyone using the same tools. So today I have data scientists that go off, well, previously I had data scientists that go off and use SAS. I have IT developers that are using Informatica if they want to do things, or they're going to go do a stored procedure in their database of choice. And I have end users that are accessing random databases, or maybe have an Access database on their desktop. And it really starts to kind of at least bring people to a single platform. And it allows us to basically, if a user has a problem, you don't have a small team that knows how to address what they need. You have a bunch of different IT teams that all do it the same way, and a lot of business users that are getting more and more advanced and can help them as well. So within IT, our expectation, and what we've seen so far, is that our IT and advanced users can start doing some more complex data models and some large data transformations and processing. They can build those enterprise data sets. So if they build a data set that they say is good, with OData 2, all it is a checkbox for us to say, now it's OData. Everyone can access it. You don't have to grant permissions in the database. And for those that know what they're doing, they can start building their predictive models and machine learning, because in general, Databricks is what we're pushing everyone towards in order to do that type of work. For our mid-level user, there's a lot of kind of similar interaction where they may still want to modify enterprise data sets. So there's an OData feed that has everything they need except this one column. And rather than have to wait 3 months for IT to go deliver it, that raw data is already there and the data service is there. So just write a query that combines them. And maybe we just use your code to then make that the new OData. They can create brand new data sets and write them back into Snowflake. So every user, as they get onto Snowflake, has their own personal space where they can do whatever they want. we're not going to monitor it. We give you no SLA, but have fun. We will watch consumption, and if you're doing something crazy, eventually someone might yell at you. But and then we have team spaces. So as people say, all right, I've built some things, I want to have a team space. So we've started creating schemas that allow everyone to share within their team. What we are starting to stand up now is the governance for how do we go from a team area to enterprise. We have to make it lightweight enough that we have to make it both lightweight and advantageous enough for them to say, okay, I will go through your process in order to make it an enterprise thing. And that might be the line that we draw in order to make it OData. That's a thing that we're trying to develop and figure out what's the best way to address that. But ultimately, we don't want to hold anyone back from sharing within their team and being able to share their insights. And then lastly, we have the consumer. And really for them, they shouldn't feel anything differently if they're just updating a dashboard on a nightly basis. It's going to feed from somewhere else. But ideally, they will feel little to nothing. So some of our early benefits, cost reduction. There's cost reduction all over the place, but one to call out. I mentioned one of our analytics tools that we use, and I won't rename it here, but ultimately we cut our spending by 70%. We were spending almost $1 million. That 70% actually funds both Databricks and Snowflake for me over a year. Over time, as those get really big and important, or more important, they maybe won't quite get there. But it was a huge win for us, as well as that's a service we have to manage, and there's a lot of mess with that, and it does not play well with other things. So cost reduction, we've seen it on a bunch of other tools, and there's a bunch more coming when we start retiring the Informatica things. Our data warehouse is insanely expensive on an annual basis to maintain just from the licensing. So as we start hitting those things, our projects basically fund themselves. Our decrease in support. So when my team started, we had 2-3 dedicated admins. We lost one because she was offshore and she went to another company. She wanted to move to Australia, and good for her. And then we, through Devon, hasn't been immune to some of the market challenges. And so when we had a layoff, we had someone decided to leave, and we just didn't backfill him. He retired, so he's very happy right now. And really, we haven't had to replace these people, because as we've gone, we've ignored the on-prem stuff and just made that experience slowly worse and worse for everybody. Planned obsolescence, and then
that way they're more willing to move on.
Exactly, yes. And we really, there's a bunch of things that we still want to do as far as how we manage our systems. We want to be more automated and that kind of thing, and that's the main thing that we've probably lost by losing some of our people. But ultimately, these things run and they're up, and I don't get calls in the middle of the night because there's a problem. It just works ultimately, and so it's made that side of things just dramatically easier for us. Future scalability, I don't worry about having to, our Hadoop instance 2 years ago, we were like, oh, we need to upgrade, and there's a lot of things we need to do, and we just decided we'll just hope it stays on for another couple of years until we can shut it off. And we don't have to worry about that kind of thing anymore, because we flip a switch or click a button or do something, I don't know, and it just works better. And it's been amazing. And then ultimately a decrease in complexity. So as we start removing some of our other moving parts, and we all kind of agree on this is how we do it, then it's just fewer things that we have to maintain and deal with. So I think if I remember my slides correctly, I just have a couple more that are just really my own personal thoughts on the cloud. Obviously, I'm pretty high on it, but I do actually have a couple things that can be a struggle. So advantage of the clouds, I talked about elasticity a bunch of times. When my team, and well, no, I'm going to get to that in a minute. I'm going to talk about failing soon. So we can elastically increase and deal with anything, and that's a huge win for us. Speed of delivery, being able to bring on new tools very, very quickly. If it's a thing in Azure, we can just check on it in the marketplace, and we've got it. And sometimes I'll get in trouble for spending too much money, but it's just so quick to get it online, test it, and then shut it down if it's not the thing that we want. Being able to separate that compute and storage, being able to store our data for cheap and not having to worry about it, and then when I need large-scale compute, I just have access to it, is huge. I'd say it's cost-effective, but not always cheaper. There's plenty of things that we've done that are just more expensive depending on what we're doing. I called out a process here called SW4, which is some subsurface modeling thing that literally runs twice as fast as you scale up your compute. And so our on-premise instance would run for, I think, 2 weeks when they wanted to do something. And they always wanted to do it faster, but we weren't going to go out and spend $5 million on a faster machine. But in Azure, we just have a much bigger machine that we bring online, we run the process, and then we shut it off, and we stop paying for it. And so we pay the exact same amount we'd pay if we were to run it for the 2 weeks in Azure. And then kind of the advanced capabilities. So I tested this last night. This slide's like a year. Oh, I don't have the internet here. Never mind. Well, this did still work last night when I clicked on it. A guy on our team, a few of you guys know, his name is Mike Bach. I like to make fun of him a lot, but he used to own Power BI at Devon, and then he handed it to me, and I've made it way better since. But he built, basically, he doesn't know, he's not a developer, but he built a front end that took we use Yammer, which is basically Twitter for the enterprise. It's a disaster. No one should ever do anything on Yammer. But when he ran it, he was able to get access to the data under Yammer and then build a dashboard using the intelligent services in Azure that could get him sentiment analysis against that. He's not a data scientist. Again, he doesn't know what he's doing, but he was able to build a thing that could show this is how people feel about the different Yammer groups. And it could tell them who was positive about the groups they were in or who was only really reporting problems in the groups they were in. Interestingly enough, the group that he owns, which is the Reporting and Analytics Community Practice, or used to own, had one of the most negative things in Yammer. So, and then lastly, fail fast. I mentioned it a lot, but in 2017, we just failed all the time. Nothing worked the way we thought it would, and if we had actually tried to purchase all of that, I wouldn't be here today. I'd be working somewhere else. So we were able to quickly stand things up, shut them down, figure out what works, what doesn't. And we ran through so many tools to see ultimately what worked best for us. And last thing, so potential pitfalls. The cloud is great, but it's not always great. So outages occurred, 99.9% uptime guarantee on just about everything in at least Azure, which 99.9% isn't quite as much as that sounds like. That one day a year when it goes down, or a fire starts in the Dallas data center, and you have your Active Directory or your ping authentication in order to get into all your things is out of that one, so then you can't authenticate to anything else. Things can go wrong, and you have to be very mindful of that. Rogue technology being stood up. I had a business user ask me how to do something in his in the server that he stood up in Azure, and my first response was, "Why do you have a server in Azure? You're not supposed to have that." But somebody did something for him and said, "Here you go." The cost leaks that we have, I call them cost leaks in general, just people forgetting to turn things off. Oh, I'm going to poke fun at Murphy. So Murphy used to, this is Murphy, everyone. Murphy used to work at Devon and moved on to bigger and better things. And when he left, someone said to me a couple months later, "Hey, do you know what this HD Insight instance is?" And I said, "I have no idea." And I asked a few people, and they're like, "Oh, that's Murphy's." And so I don't know, spent a decent chunk of change on a thing that we just didn't know was out there and all that. We'll get better at that kind of thing over time. But for now, when people forget to turn things off, we just forget. And so everyone has to be mindful and start to be held accountable. Latency is a problem. So you can put your stuff in whatever data center you want, but you need to make sure those things can talk to each other in a decent amount of time. Interestingly, a challenge, it hasn't been as much of a challenge as we would expect, but it's something we have to address. Our Databricks instance is on the West Coast, and our Snowflake instance is on the East Coast. And so when we run a job, we have to pull it across the country like 4 different times. It seems to still be working fine, but we also pay egress charges, and there's some back and forth. So latency and where you put your systems and all that can be a struggle at times. And ultimately, the Devon learning curve. Because my team was, as I said, born in the cloud, we got to ignore all the old stuff and just start doing stuff in the new way. And we didn't really care about a lot of the processes and how Devon used to do it because it wasn't our problem. And so a friend of mine that runs the security team called us the IT boogeyman because we just went and did whatever we want. And we kept getting mad at people like, "Why are you stopping us from doing this?" And the cloud is just ultimately a very different way of operating for any IT shop. And so when you have people that are used to doing it one way and now everything's completely different, it takes a little while to get going on that. Things are much, much better now. No one's gotten mad at us in a while. at least not to my face. And so, but it's an evolution for, I think, most companies as they start getting going on that. So that's all I had in structured content. I have other random slides here that probably won't make any sense. I'm open to any questions you guys want to ask or.
So you kind of scratch your face at Attunity. Do you have an idea of, like, are you looking for something similar to replace that, or?
So the question was my lack of a poker face on Attunity. No. So we will make Attunity work. Some of our problems on Attunity are just dumb. Like we have a very large database, an Oracle database that's replicating, I don't know, 50 million records from one of the tables. And in some cases, it's taking 24 hours for it to show up in Snowflake. That's just us doing something stupid. So we actually have Attunity coming on site and working through those issues starting next week. You probably just see me in the trough of despair right now, or it's just like, why isn't this working? So I'm not overly concerned about the Attunity stuff because we've talked to plenty of customers that everything's great for them. I think in some cases, like the Snowflake connector for Attunity did not exist when we bought Attunity. We knew that it was coming at the end of September, so technically we didn't even have access to the connector until a couple months ago. So we're really just working through some of our troubles right now. But in the meantime, we replicate data in other ways. We use Azure Data Factory and other tools like that just to get us through what we need for now. We just don't have that near real-time look that we ultimately want. Yep.
Is it your goal to put every relational database into the data hub?
That is, the question is our goal to put every structured relational database into the data hub? That is ultimately the goal. In general, with something like Attunity, once you put it on a database, there's not anything left to do except click select all, and it just starts replicating. So in general, there's no reason not to. The heavy lifting is just putting it on the database, which is really just a DBA activity. So our general motto is if you touch it, take it, and put it all in there. In general, once we get 20 systems or so, that's going to capture 99% of our use cases. And we already have 10 systems replicating today. It's just, hit or miss on how well it's working at the moment. Yeah.
Do you plan on going the same or similar with like the telemetry data or your SCADA system?
So the question was, are we planning similar with our telemetry and SCADA systems? It is a planned thing for us. We have not figured out kind of what our strategy for IoT and that type of work would be. Right now we use PyHistorian for all of that, and we have built processes that can stream data out of Pi and then run a prediction or an algorithm against it or simple data transformation and push it back. So we kind of have that as an interim, as well as we've actually just recently connected Databricks to Pi, which we've never recommended to anyone to actually do because Databricks can and will destroy a database if it can't handle it. But we were kind of sick of having the discussion of trying to get all the data out of Pi, so we said, just go for it, but be careful. So we're kind of on a longer term journey to address all of that, just because there's a lot of field sites and a lot of technology out there that's not ready.
So you're saying you're willing to come back in 6 months and send you?
I will be happy to send the guy that I pushed this off to, and he can come talk to you guys. Yes?
Are you using any other engines besides Spark?
Any other engines? Engines like what kind of?
Like Presto or?
So the question was, are we using any other kind of engines other than Spark? So we did evaluate Presto somewhat briefly. We evaluated all the different versions of HD Insight things that we could put on top of it, including, what's their main one I'm blanking on? The Hortonworks, it's the equivalent of Impala for Hortonworks. We also used Impala. We were Impala customers previously, and we did an evaluation of putting Impala on top of this. So we looked at a lot of different things, and ultimately we found that Spark, for the things that we feel like Spark is right for the distributed processing, that was our way to go. And for the traditional BI interaction, Snowflake just seamlessly filled that gap for us.
What about OLAP?
So OLAPs, so in general, cubes aren't going away, and what we do with them isn't necessarily going away. The goal is to decrease the number of them that we have. So for example, we have an AP side of our warehouse, and that has amazing capabilities where it can show someone they're in Excel, and they can keep drilling down, and they can hover over and see additional details when they hover on it. and they can double click and the invoice image will actually pop up for them. And that's all those types of things are experiences that I'm never going to be able to compete with. And ultimately, Devon's a big Power BI customer, and since that's all that under the hood, it's for certain use cases, we're never going to get away from that. But we do expect to decrease how much we do that kind of thing. So we're trying to do it less, but we will still do it.
So would you say that Snowflake feeds those, or is it?
Does it, sorry, one more time?
Is it do you use Snowflake to feed?
That is the plan. So the question was, will Snowflake feed the OLAP layer? And yes, when we start addressing, in general, anything we do there is fed from our warehouse. So as we start swapping out the warehouse, then we'll just write to that instead, which will be good for our users because they shouldn't feel much pain. I'm sure something will go wrong, but it should be somewhat seamless for them.
Does your business community use Databricks?
So the question was, does our business community use Databricks? Yes. So it changes based on the group. So our advanced analytics team, our data science team, they do. They were primarily one tool, and now they've almost completely moved over to Databricks for what they need to do. They still use that tool occasionally, which is why we still have it, but for most of what they need to do, they use it. We have engineers. Devon has a unique opportunity in where we have a lot of our users are engineers and other people that their job is just to deal with data all day. So we do have a lot of opportunity where they can actually handle some of these more difficult tools that might be out there.
Did you evaluate other cloud storage providers like AWS?
So yes, I do have a slide deck where we showed what was good about AWS and what was good about Azure. By the time my team got in there, the Azure decision was made. We did look very closely at just going rogue, and we had approval if we felt it was the right thing to do. But we looked at the differences between the two and where we thought Azure was going to get to, and decided doing everything ourselves that we ultimately would have had to do, we probably would have failed. So we went with Azure. And in hindsight, it was the right call. We're good with it now. There were certainly struggles in the early days.
So what's the current status of Hadoop? There's still that on-prem cluster is still running and doing some jobs, but not, you're trying to offload it as quickly as you can.
Yeah, so there's two things that run in Hadoop today. There's all those Datamere jobs, those 800, and that's really the only barrier to shutting it down. The other job is just one large-scale query that basically can take all of the production in the U.S. for all of time and separate it by formation, and then we have a GIS map that sits on top of it, so it's a heat map and they can drill into it. It's really cool. It won't be hard to port over because that query will run just fine and we'll materialize it in Snowflake. But the only thing that really keeps our on-prem cluster alive today is the Datamere processing that happens on top of it.
What do you do with the results of your Spark jobs in Databricks? Do you then push that back into Snowflake, or?
Yes. So that's if the goal of the Databricks job was to transform the data and do that, then we write it back into Snowflake. So the goal is if you have anything you're looking to do, extract it out, transform it, which is why we look at Databricks as the front end for our data hub, because ultimately we want someone to push it back into Snowflake. Since it doesn't really cost us any money to store that data, we want it to all be in there.
I guess I'm struggling with that because we're looking at Snowflake and I see my data ingestion going into Snowflake and data results still being in the same place, and that confuses me. Maybe I'm just easily confused.
I'm a slow person. Can you ask again? I don't think I followed.
I feel like I'm mixing multiple data sources, right? I've got these raw data sources that I don't particularly want anyone to be looking at, right? And then I'm transforming it so that it's available to do analysis against via Spark. We use Spark streaming to do that.
Mm-hmm.
And I feel like I want them to be separate, right? But I feel like if I put them all in Snowflake, I don't feel like they're separate.
So that's fair. So we've used the databases inside of Snowflake and the schemas in order to handle that. And at the same time, where I think we're different in our philosophies is we do want people to have access to that raw data. So for now, we've not put anything that we consider sensitive in there. So anything what we call tight hole, the wells that we're working on that we don't want people to know, or the areas that we're exploring, which is a very small subset. We haven't put any of that type of data in there or any of the HR specific data. But we want people to access the raw data if they're comfortable. Our basic thought is if they think they can go into this random system and look at a table and make any sense out of it, then they're probably going to do it anyway, so they might as well just access it in my place.
Do you think you'll get to a place where you feel comfortable keeping sensitive data in Snowflake?
Yes, we're going to have to. So we're not as deep as we'd like to be on the security side of it, so that's why we're focusing on delivering to the bulk of the enterprise, but we have land data. That's probably the primary thing we're missing that we'd like to have that holds us back a little bit. All the land we're exploring and we don't want people to know about, we've just intentionally said, for now, we're not putting it in your system. We can stand up just a different Snowflake if we want to say, all right, you guys can just go use this one if you want. It doesn't really change how we operate. That's all free, just we pay for the compute on top of it. But for now, we feel okay with it. Yes? So the question was how do we plan the disaster recovery? So with both Databricks and Snowflake, they take care of that for us. I don't explicitly know how Databricks handles it, but I know that Snowflake replicates between multiple data centers. So all of our data exists somewhere else, I just don't know where, and it's available. And that was actually the other, that kind of just made me think about the uniqueness of Snowflake for us, and an area that I thought would be a bigger problem was the data that's in Snowflake, it does not sit in our Azure tenant. So it's in someone else's tenant, and it's outside of Devon, which is a lot of data, and especially if you start doing secure data. I thought that our more senior leadership would panic over that, and maybe they just don't know. But it's been that was a different thing for us because we've been very controlling. That was part of our struggle with moving to Azure and what we did, because everybody wanted to have everything inside the Devon internal network and not take advantage. HD Insight and Databricks couldn't talk to our internal systems because those are public and these are internal and those types of things. So I kind of went off on a tangent from your question, but in general, they just do it for us.
Do you have any kind of specialized network backbone between?
We do. We pay for line from, blanking on the company, but yes, we have a dedicated line to like 4 of the Azure regions today and pay for that.
Do you have any examples of the benefits of querying with your new system compared to how it would have been in the past, such as the overtime data that you were discussing earlier, the GIS information?
So I don't have any metrics. The question was, do I have any kind of data to show what it was like before and what it's like now? And the answer is no, but we do have, I guess to start, in a lot of cases, Snowflake is not necessarily the fastest thing. Like for a small query, SQL Server is going to be faster. Impala could be very, very fast. You just needed a massive, massive cluster on-premise to do what you needed to do. But what we found was it was fast enough. I can provide one example when we were evaluating Snowflake that we did. We have a table that we call LogSifter, or a system that we call LogSifter, where they basically take files from subsurface and try to bring some form to them and ultimately capture that data for analysis. And that, at the time, that table was 46 billion records in an Oracle database that's running out of gas. And I hear now it's up to like 90 billion, which is scary how fast it's grown in the last 6 months since we ran this test. But when we were evaluating the 3 main platforms that we were looking at, which was SQL Data Warehouse, Snowflake, and Impala, we ran a concurrent query, 1,000 concurrent queries against that table with random, what we call curve IDs. So it's a very long and very skinny. It's a 3-column table. And so we ran that, and we actually got, between SQL Data Warehouse and Snowflake, we got similar performance. So we could run on a medium-sized cluster, which costs $5 an hour, I think, from Snowflake, non-discounted, depending on how well you negotiate, I guess. And it would return in less than 5 seconds for all 1,000 queries. And so it scaled really well, and it delivered great performance. In some of the smaller sets we did, sometimes SQL Data Warehouse would be a little bit faster, or if we just ran something at SQL Server, it'd be a little bit faster. But ultimately, it could meet all the needs.
Are you guys running into any timing issues with on-prem data, stuff in the cloud as you work your way through the transition? Basically having stuff for people to read like starting at 6 a.m. in the morning or anything like that.
So the question was, are we having any issues with timing as far as, with all the processing that has to happen on-prem and then get into Azure as we continue to migrate? And just nightly SLAs and processing, what does that look like? Yes, especially as we started some of the, I guess I'd say Devon's about 50% in the cloud at this point. So a lot of our things are now up there, but not everything. And just depending on where we are in all the different tools kind of dictates how well that's going. So when we moved Informatica, it was just a mess. Things were taking a long time to process, and similar to what we're kind of seeing with Attunity, we got to dig in and figure out what's going on with that processing and where's that choke point that's causing us a problem. In most cases, it's been fine and manageable. I guess the other thing on cloud that's been a struggle for my team is for a business user in a lot of cases, if you're just doing IaaS, which is what a lot of Devon's been doing, the goal is get to the cloud and then start being better. For a business user, the cloud kind of sucks. Like it's not good for them, because if we're just using a machine on premise and a machine in Azure, it's probably going to be better on premise because we spend a lot of time making sure there is no latency and everything's amazing. However, when you start converting them over into the PaaS and SaaS offerings and what those things can do, then they benefit a lot. So when we try and talk with users and say it's going to be great, and they say no, it's not. But you start to show them what you can ultimately do with these new tools, and it kind of changes the conversation. So yes, there's been struggles on those things.
What do you use it for scheduling jobs?
This question was, what do we use for scheduling jobs? We use today on-prem and in the partial cloud Title for data. However, for Databricks and all that, we're using Azure Data Factory as our orchestrator or scheduler. Yep.
Some of the data you collect should be from documents, right? So what kind of tools do you use for data extraction from documents?
So I glossed over it because it's confusing to me and I didn't want to have to deal with it. Azure Blob Storage. So we used Azure Data Lake Store originally. That was kind of, the question was, what do we do for basically unstructured data? And we actually have gone pretty far into this at this point. So we used Azure Data Lake Store, and which was their original, here's a faster layer for unstructured data. They have since deprecated that, or they're in the process of deprecating it. They always had Blob Storage and ADLS, and they said, no, ADLS is the future. And then they said, never mind, and they said, Blob Gen 2, or ADLS Gen 2, which was Blob. So we've been moving over there. That's ultimately where we where we're working on putting unstructured data. So we actually put all of our SAP invoices. We have 6 million documents from there that sit in here, and we actually did very large scale OCR and compute. We have an RPA process that we built out that can see what's on the invoice and classify it and enter the data into a system. And we did that using this process where we dumped all that data into the Blob Storage and built some processing in Azure on top of that in order to identify and classify all those and execute those. So as we have the ability, our content management system, which is, I don't know, 30 or 40 terabytes, we've dropped into Blob Storage for future processing and things like that. So Blob Storage for our data lake, or it's really Snowflake for structured and then Blob Storage for unstructured. We've used, so primarily for that use case, we used whatever the Azure one is. I forget what they call their cognitive service for that. But we used that, and it did a good job. They have two, so they've got a type one and then a handwriting one, and they're working on merging them into one thing. But we used the type one in order to OCR it and process that data. We've also used Abby. That was the first technology that we used as a part of the RPA process, and that was a good tool as well. But it's not a cloud native tool.
I was gonna ask, what's kind of stored in Databricks? Is it really just kind of like the jobs and configurations, queries? Is there any actual data that you can keep there, or?
So there is some data in there. There's something called Databricks Delta that can be a little bit of a faster engine on top of it. Sorry, the question was what data is in Databricks, or is it all outside of it? So Databricks Delta is out there, and a thing we've been looking at and kind of considering for some of our streaming processes. We have some security data that goes through there to be processed. We were using it somewhat in some cases, and just, I mean, under the hood, it actually pushes down to Blob for those things, but now we've converted all that to Snowflake. So in general, if you see it in there, it should be in Snowflake, or we forgot about it and we need to move it over to Snowflake. Yep, did I answer your question? Sorry. Okay, all right, well, thank you for your time.